Okay, so now let's really take a look at how to find this standard deviation. All right, so how to calculate standard deviation. Because what we did was we just found the deviation, right? This problem said find the deviations, but now we're finding standard deviation. Okay. So I think a table is best. First, let's look at the standard deviation symbol. Okay, so it has two different notations. A lowercase s can imply standard deviation if we're looking at the sample, right? Or this lowercase Greek letter sigma, right? Greek letter sigma. So we're going to be making a table here. I'm going to give myself a little space. Right. Our first will be just our data items. All right. First. Second will be your deviations. And that was what we just did. All right. And then third will be each deviation taken to the power of 2. All right. So let's take a look. If our first is our data item, that's just x. Deviations, we subtracted your x from the mean. Now your third step is a deviation taken to the power of 2. So that is what we title them. Okay. From there, we do all this work, include all these numbers in there, right? Now we continue on over here. This will be your fourth step. Is to sum the last column, right? So all these numbers, you add them up, that goes right in there. Here is your fifth step. That's just going to be n minus 1. Let's not forget n is the total amount of data items. And then our last step, I'll make this a little bigger here, is your standard deviation. All right, that's the sum of the last column. All right, so that's our sum divided by n minus 1, and we take the square root of that. In other words, we could say sigma here equals the square root we summed. All right, that last column divided by n over 1. That's our standard deviation. Right, that's the formula for it. But we're going to break it up in these 6 steps. All right, so 6-step process. Let's take a look at an example here. All right, let's go back to our example of these. What do we see? Of these specific numbers, 69, 69, 68, 65, 64, and 64. All right, so our numbers once again were 69, 68, 65, 64, and 64. So, in order to use this table, first thing is our data items. Second is the deviations. But in order to find the deviations, we need to know the mean. So that's really what we need to do first beforehand. Right? Excuse me. Excuse me. All right. So let's find our mean. All right. So we did this earlier, but we'll do it again. 1, 2, 3, 4, 1, 2, 3, 4, 5 data items, right? And we got 330 over 5. So this is 66, right? Now we can make our table. And put my numbers in there. 69, 68, 65, 64, 64. Okay. And I do my deviations, right? We do 69, 69 minus our 66. So here we get 3, right? 68 minus 66. So we get 2. 65 minus 66, we get negative 1. 64 minus 66, negative 2. 64 minus 66, we get negative 2. All right, we can add them all up. They should equal 0, so it checks off. So we can continue. It's a good idea to check because you don't want to do this whole table and then get it wrong. Now we're going to take each one of these numbers and take it to the power of 2. That's 9. 2 to the power of 2 is 4. If you're using a calculator, make sure you put that negative 1 in parentheses. And you get 1. Negatives should always go in parentheses. And now we add all these numbers up, right? We do 9 plus 4 plus 1 plus 4 plus 4. We add all those numbers, we get 22. Our next step is our n minus 1, right? Once again, n, how many data items? We had 1, 2, 3, 4, 5 data items. So 5 minus 1, that gives us a 4. All right, then our last step here. All right, our last step is to do what? We do the square root of 22 over 4. All right, and that will give us our standard deviation. So we see that our answer here ends up being 2.35. So that's a nice example of finding standard deviation. Okay, let's take a look at one more example maybe. How about example B? What if this time I make it look like a frequency distribution table? Or like a histogram, I'm sorry. All right, we have 8, 9, 10. And we have, how about 1? Sorry, I don't know why I'm writing it like that. 1, 2, 3. 8 is seen 2 times. 9 is seen 3 times. And 10 is also seen 2 times. Right, so we have to find our mean first. And let's not forget, this is 8 is seen twice. 9 is seen 3 times. 10 is seen twice. Right, that's what really that means. So our mean is an 8 plus an 8 plus a 9 plus a 9 plus a 9 plus a 10 plus a 10. Divided by how many data items? We have 1, 2, 3, 4, 5, 6, 7 data items. So we add this up. All right, 8 plus 8 plus 9 plus 9 plus 9 plus 10 plus 10. We get that to be a 63. And we divide 63 by 7, so we get our mean to be 9. From there, we can make our table, right? We have x minus our mean, and then we have x minus our mean, which we take to the power of 2. And what do we have? We have an 8, we have an 8, we have a 9, we have a 9, we have a 9, we have a 10, and we have a 10. Right, so you can always do it the same way. As you continue, you might find some tricks or some other ways to do it, but this will always work. Right? It'll always work. And we do 8 minus our 9, 8 minus our 9, 9 minus our 9, 9 minus our 9, 9 minus our 9, 10 minus our 9, 10 minus our 9, right? And we see we get -1, -1, 0, 0, 0, 1, and 1. And once again, we take each one of these to the power of 2. And once again, negatives should always be in parentheses if you're using your calculator. You add this last column, 1 plus 1, 1 plus 1 plus 0 plus 0 plus 0 plus 1 plus 1. That gives us what? 4. All right, so remember, there we sum. This is n minus 1. So we had 7 data items. We subtract 1. We get 6. Now this is just the square root of 4 over 6. This will give us our standard deviation. And just learning how to use your calculator to put that in there. You should have a nice button that does that for you. And how about we round this to the hundredths? They'll ask you. All right, so this gives us a 0.82. All right, so nice examples on finding standard deviation. And if you have any further questions, you can just let me know. Thank you.